So at this point, you're thinking to yourself, this is powerful. This tells us where extreme values happen. We could call those maximums. We could call them minimums. It all depends on whether it's upward opening or downward opening. Now, before we get too far into this problem, this is an interesting problem in that it really does a good job of modeling real life. So I'm going to read it to you. It says, the revenue earned often increases, then decreases as the price increases. So let's just look at that first sentence. The revenue earned often increases, then decreases as the price increases. Now, we're comparing two things, revenue and price. So the first thing I want you to think is, if you didn't charge anything for it, you may sell a lot, but this isn't asking that question. This is asking, what's your revenue? And if you're not charging anything, your revenue is 0. So you start right there at 0, 0. And similarly, there's a price after which no one's buying anything. There's a price so high that the revenue returns to 0 again because no one's buying anything. So first off, convince yourself that there's two places on the x-axis that this curve crosses. One at the origin and one some ways out on the x-axis. Now, this is a parabola, right? As more people buy it and the price goes up, that's going up pretty steeply. But there's a point at which, as you continue to increase the price, people are stopping buying the product in the quantity they were before. In other words, they're buying less as the price is going up and the revenue starts to go down again. So this is a downward opening parabola. Now, something else that's going on here is the notation that we're using. And what we're using with our variables. So let's take a look at the second sentence. It says the revenue in thousands of dollars, so make sure your answer is in thousands of dollars, is a function of the price in dollars. So there's a new mathematical word. You see that throughout math and the sciences and business and anything like that, the function. So I'm going to introduce function notation here, in addition to some variables that I think you'll agree were good choices. So it says that we're going to find the price that maximizes the revenue and the maximum revenue. So there's two things going on here. There's the price, we're going to call that P, and there's the revenue, we're going to call that R. And we expect the revenue to start at 0, go up to some peak at the vertex, and then go back down to 0 again when the price is so high no one's buying anything. So here's our formula. This is a downward opening parabola. I know that because the coefficient of the squared term is negative. And that makes sense. It goes up and then down. Well, that's the definition of downward opening. It says find the price that maximizes the revenue and the maximum price. This is a function, and this new notation here is brand new. So if you've been trying to do other things while listening to this video, pay really close attention for the next few seconds. This notation is not going away. It's so powerful that we use it throughout math and the sciences. The parentheses around the P after that capital R do not mean multiplication. They're not a grouping symbol. They are none of the uses of parentheses you have seen before. This is a brand new use of parentheses. This is function notation. It does not mean to multiply. It is not the base for an exponent. It is not a grouping symbol. This is function notation. It's read of, which is even worse, because of is how we say multiplication. So in a few seconds, you're going to hear me say R of P. Now, if you've been paying attention in a math class, you know from early days, from fractions, you know that of is a key word for multiplication. So you're hearing something that sounds like multiplication. You're looking at parentheses, and it looks like multiplication, but it is not multiplication. It's a way of reminding yourself what price you're talking about. So when we plug in a particular price, we're going to put it inside of parentheses there, but it is not being multiplied. It's a reminder of the price that we plugged in. So we're interested in finding the vertex. We're interested in finding the maximum value here, the price that maximizes the revenue. And of course, that's the vertex. So to do that, we're going to say negative b over 2a. That's exactly what we've been doing. Negative b, well, there's our b, 128. Negative b makes that into negative 128. we're going to multiply 2 times A, or A is -8. We do the arithmetic. I did this with a calculator, and I got that the price should be $8. So it looks like the price that maximizes the revenue is $8. Well, that's great, but what's the maximum revenue? And now that new notation is going to come into its own. So make sure that when you look at this equation for the first time, you see that we're using this function notation. This means the revenue when the price is 8. And rewind that and go over that again if you need to. That's the revenue when the price is 8. It's not multiplication. It's not the base for an exponent. It's not a grouping symbol. It's saying that I'm plugging an 8 into my equation for revenue. And you'll be given that. This isn't a business class. I'm not going to make you make up that equation, or calc class. So I'm going to plug it in, just do some arithmetic, and out popped 512. Now 512, remember, is the revenue in thousands of dollars. So that's actually about $500,000, a little bit more than $500,000. That's $512,000. Now, not a lot new here. You saw the vertex in the previous case. You know how to substitute a number into an equation. Really, the only new thing here is this function notation. And at this point, if you're willing to accept that there's a new use of parentheses that doesn't mean anything like what parentheses have meant before, it's a notation for saying the revenue when the price is 8 in this example, then you're in good shape. Let's look at one more of these. We go through it a little bit quicker. The questions are all set up the same. They look the same in my open math. The revenue in thousands of dollars is a function of the price in dollars, and there's that function, that equation. The revenue as a function of the price is -22 times p squared plus 132p. Again, it says find the price that maximizes the revenue and the maximum revenue. So the first thing we're going to do is find the vertex. That's -b over 2a. So we're going to go grab our b, 132. We're going to change its sign, -132. In the denominator, we're going to multiply 2 times a, 2 times -22. We do some arithmetic, and out pops $3. So the price that maximizes the revenue is $3. So let me point out what that means. If you raised the price to $4, your revenue would go down. If you lowered the price from $3 to $2, your revenue would go down. It is the price component of the vertex. Now we also want to find the revenue. So we know that P equals 3. So wherever we see a P, we substitute in 3. So we do some arithmetic, and out pops 198. Remember, that's interpreted as thousands of dollars. So that's about $200,000 in revenue.